Hello everybody, thanks for stopping by for another Screwy Tuesday. This will be a fairly short one, I hope. I'm going to run through some items and then we're going to go on a road trip over to Carl's, my good friend Carl, and we're going to talk about his Revette lathe and the Enshoe mill. But let's start off. I got some notes written here on the board. The first one is I got a viewer gift from Mike Nixon. He had sent these coasters that he had made out of aluminum. There's felt on the back. Did a really nice job on them. There's 4 of them that he machined. And I wrote Mike, dummy me, this came with it, and I was perplexed on what it was, and I actually sent Mike a note back. He did some nice machining on it, and I was trying to figure out what the heck it's for. It's got felt on the bottom, and I was thinking of it as a tool, and then just as I was setting up for this video, finally I realized what it is, Mike. It holds the coasters. He did a nice job. Interesting enough, as soon as these came out of the box, he sent me a nice Christmas card, and my wife said immediately, nice, those are going to be on our table. Candle holders and wine bottles fit on those also. So Mike, thank you very much. Really a nice gift. I appreciate it. It's really cool when someone takes the time and makes something for you and sends it to you. The next item is the steady rest that I showed last week, trying to find out if anybody knew the manufacturer or what lathe it fit. I got an email from a viewer, Bob Curley. He's back in Michigan, and it fits his Rockwell 14. So he and I struck a deal, and it's in the mail to him, and I'll be curious to talk to him. The box weighed it's only 29 pounds, I think. It felt like 45 pounds. I put a box inside the postal box, and it'll be interesting to find out how it survived once it got there. It wasn't a Ox Tool approved box, but I think it'll do it, so we'll see what happens there. I'm also in this video, I hopefully will show you a couple of shots that Bob sent me of his shop. We're basically about the same age, and his shops are somewhat similar. He's got a really nice setup. He's got a separate wood shop also, and he's on some acreage back there. So Bob, thank you very much. Another item is, here's a shot of a exhaust, a bracket to pull an exhaust tube up on a manifold. Another viewer, Chad, that I've bought some parts from in the past. He's a mechanic here local, and he asked if I could machine this part for him and open it up to 250 thousandths, and I said sure, not a problem. So it was interesting. As I said, send me a photo of what I'm going to machine, so I could figure out how I was going to set it up. And looking at the first photo of it, I just didn't think that it would fit in the 3-jaw. Well, eventually it did, and I might even clip in a little video here of it howling in the video, or in the 3-jaw. But as I looked at the photo and said, how am I going to set it up? Well, I said, well, if it doesn't fit in the 3-jaw, then maybe I'll mount it on a faceplate. And I have a faceplate here. I covered it up. I have a faceplate here for my closing, and I said, well, I've never used it. I bought it, never used it. And I said, well, if I'm going to mount this piece on here, I need to put clamps, and these are 5/16 bolts. Everything I've got is either larger or smaller. So now I got a project. I got to build clamping for this faceplate. But anyway, the part turned out well, and Chad has it back, and I hope it works for him. Let's go on to the next little quick subject here, ultrasonic. So this is the ultrasonic unit, a Fisher FS30 that my good buddy Chewy gave to me, and it didn't have a basket, so I cobbled a basket together. I went over to a scrapyard and picked up a perforated piece of stainless. Nothing real pretty that I built, but it works. I was really just curious if the whole unit worked. And so let's talk about the ultrasonic. I didn't do it before and after, and I should have, but it was just one of those days. So I don't know how that'll come out, but that bolt looked worse than this one, and I was just amazed at how well it cleaned that bolt. While this bolt was in there, Ryan Wasella in IL Gopher, Ryan and I, we communicate every now and then, and he had sent me this compound off a South Bend. It might be on 2 years now, and it sits back here on my tabletop in a tray, and I pick it up every now and then and wonder about repairing it. So you can see where somebody had repaired it and welded it back together, and I guess it fractured again. So it's been sitting there, and so I said, well, heck, this is a good one to try the ultrasonic. So I put this guy in there, and I mean, it's just amazing how clean it came out. I didn't leave it in longer to take all the paint off, but it basically took all the paint off, took all the grease off of it, super clean. So it's getting closer to me seeing if I can actually glue this thing back together, Ryan. I don't think it'll be a success, but it's on my list of things to do. So maybe a couple of years still. And the cleaner was going, this was the other piece, and I wish I would have taken a before photo, but it's just amazing how well it cleans. So if you guys can pick up one of these guys, I'd suggest it. Okay, we're going to head over to Carl's, but I thought I'd mention one other item. Here's a photo of me back at college. I went to UC Berkeley for about 1.5 years. I was there on a track scholarship, and here's a photo of a fella I just talked to. We made contact after since 1974. I lost track of him. He ended up in Canada, and through another fella from running track back in the day, he put me in contact with Jim, and so this is Jim passing the baton to me back in 1973, 74. And back from that photo, and then here are some photos of some builds that Jim has done, chainsaw work, and some pretty neat woodworking that he's completed. We're hopefully going to come together here early next year. He's hoping to make a trip down from Canada. So hope you enjoy the photos, and after that we're off to Carl's, and that'll be the end of the video at that. Thanks for watching, thanks for subscribing, and hope you enjoy the video. And unless Howie happens in here, there's not going to be any Howie today for all you Howie lovers.
You do your intro.
Oh, hey, we're back over at my buddy Carl's shop, and it's been some time ago that we had a discussion on this lathe, and I'll turn it over to Carl. We'll have a little history discussion and bring you up to date.
When we last left off, I had discovered that this lathe bed, when it was reground, the grinder had left a little ledge right there, and that the pieces that were mating onto the surface were being held off of it, and you could put 20 thousandths feeler inside there. And so the bed had to go back to the grinder. We put it on his 4x4 surface plate and checked the errors in it, and we found that there was a sag from here to here. It was 2 thousandths down in the middle. And what he did was he just simply picked the lathe up, put it on his magnetic chuck, and did not check the bottom of the lathe bed. When he turned the chuck on, it just simply pulled everything down. And so he had to, he didn't charge me, went back and completely reground the bed. And he says, I couldn't get any closer than 0.5 thousandths, which I thought was a little lax, but I couldn't argue with that. And when I put it back together, I figured out how to level this. And so now my precision level shows that the curve goes just a little high, goes up a little bit here, about 2/10 in 10 inches, and then drops down 2/10. So it has just a little bit of an S. The nice thing is that the high point of the S is where the turret runs the most. So I'm satisfied with the leveling. It took a lot of work to get there. When you play with the precision level and sensitive dial indicators, you begin to realize the truth of everything is made out of rubber, because you tweak something and you can see things move. You can see that bubble go back and forth. Get the wrench on there and tweak it a little bit more, and you can see that bubble moving. So everything's made out of rubber. When it comes down to something like this, you have to know how close do you want to go. Set your tolerances, get some idea. Can I go rough? Can I go tight? And then work to those. The next thing, I want to show you progress on scraping. First of all, we'll look at the headstock over here. Chuck, if you can move that just a little bit. The headstock has been scraped on the bottom and aligned. I showed you the alignment bar last time. The figures are in 12 inches of travel out here. It is about 2/10 out. I forget which way it's going, whether it's up or down, in this direction. And going this way in yaw, it's about 1 thousandths and 12 inches, and I decided to let that go. Most of the parts that will be done on this lathe are no longer than about 2 inches, and I'm going to accept that little bit of error. While we have the camera looking over here, this is the lever-operated cross slide. That has not been scraped in yet. While working on all this, I says, this is just a lovely lathe. I've got this Rivette compound cross slide, and I'm going to use that to bore this out. I'll tell you about that in just a little bit. And then scrounging around my pile, I came up with this, what appears to be a Myford, 7-inch Myford lathe, a tailstock. And I says, this is going to be a 5C collet. This would make a marvelous 5C little toolmaker's lathe. No power feeds, no threading. It's just simply plain turning. And so when I get through scraping everything in, then I'll make some bases to mount these, and this will be a combination turret and a toolmaker's lathe. Okay, we'll halt for just a second while we focus back onto the turret slide. Okay, this is the base of the turret slide, and it has been scraped in fairly close. You can see that the bluing shows various spots along here. This is not a high-grade scraping. I'm still roughing it in, but this is getting very close. Checking this with an indicator on the bed, it says that I am flat to the bed within about 2/10 and 2.5 inches of travel of the slide. I'm going to accept that. What you can't see, because of the lighting and they're very indistinct, is that the markings on the bevels here and up here are nowhere near as dense as on the flat. That implies that there is more material has to come out of the flat in order to get better contact along the bevels. While I'm doing that, there is still a yaw error. I needed to turn this. It's about 7/10 out in 2.5 inches, which is not acceptable. And so I'm concentrating now on scraping this edge here and this bevel here to turn this slide to bring it into alignment. I expect another possibly week work on this. I don't do a lot of it, and there's quite a bit of material to come off. I have seen where I put this up on feeler gauges, and there's about 2 thousandths material to scrape down here, and about 2 thousandths here, and about 2 thousandths here to get the alignment that I need. Okay, there's the progress. The headstock is done. The tailstock is about 75–80% done, and I'm beginning to think about the headstock again. We'll be right back. We're going to look at the nose of the headstock. Before we get to the headstock, I want to show you the problem that I have. The Rivette company used the 6R collets in this lathe. They did not use the 5C. I picked it up because it had already been converted to 5C, and I thought it was a good job. Well, it turns out it wasn't. What they did was they bored out the nose of the spindle, or ground it, I'm not sure which, and they put a little taper adapter in, but they did not pick up this end of the collet. The collet stuck back in there. This was not precision finished, and this was not picked up. So that the only control over the seating of the collet at the rear end was the drawbar, and the drawbar had a little bit of movement inside the spindle. So what they missed, I hope you can see this, is that they did not put this little surface right in here inside the nose of the spindle. That meant that I have to completely bore out that adapter and fit this 5C adapter. I think this is a Morse 5 taper, a short taper, and then the nose of it is 5C. To do that, we're going to go over and look at the headstock of the lathe next. Be right back. This is a setup that I'm going to use to bore this out. I've bored some of it just as a trial to see what my problems were. I've got to take this out about to here. This machine's like, it's probably a 4140, 4130, something like that. Reasonable surface finish, but it's tougher than mild steel. Certainly it's not free machining steel. A little bit of a go for this small Rivette compound slide. It's not made for high forces, but I'm going to impose high forces on it anyway. So this gets bored out about 2.5 inches, and as I said, that sleeve it'll have to be bored taper, and then that sleeve will be pressed in, and at that point I'll have a 5C collet nose again. Okay, that's all on the Rivette lathe. I'm going to show you one other little thing, just a quickie. I have another project going. It's something you haven't seen before, so we'll go over to the other part of the shop and take a look at that.
You're up.
Okay, well, Chuck reminded me that we've seen a little bit of this machine before. He said that when I was adjusting the spindle bearings, this is a plain bearing mill. No big roller bearings in here. There's just big, solid, plain bearings. And by now, the mill has been completed. It's been painted. It has made parts. It's done very well, and this one is a keeper. And I just wanted to show you. It was back in my fabrication shop before, the wood shop, where I make a mess. And just this week, I brought it out and set it on the main shop floor.
Tell me, what's the manufacturer? It's a jet.
Okay, well, Chuck is prompting me to give a little bit of the background again. Interesting story on this mill. It came off of a Japanese warship at the end of World War II. It was confiscated by the captain of an American warship. He sent one of his crews over and said, "Get that mill off that ship and put it on my ship." Well, he pulled into, I believe it was Alameda Naval Air Station after the war. And the shore patrol says, "Naughty, naughty boy, you can't be stealing this stuff. That's illegal war booty." And in 1946, approximately, it was sold to a machine shop in San Jose. It stayed there till a couple of years ago, and I bought it from the son of the owner of the shop. It was the dirtiest mill I've ever seen in my life. This thing was almost completely black. I've cleaned it up, painted it, taken it apart, fixed everything. It's turned out to be a very nice mill, very well built, very well designed. It has won a spot of affection in my heart. I learned my milling on a big Van Norman with a 50-inch taper and a 50-inch table, power feeds in all directions. So I love horizontal mills. And I hope to find a little bit of work for this and have some fun with it. So that's all we're going to show you right now. It's home. It's ready for service. I've made, as I said, I've made parts on it already. Here's one of them. Made some T-nuts. I made the trippers for the power feed. I made an extension for my brother's bandsaw. This one's a keeper. See you guys the next time around.
Remind me, what's the manufacturer?
Oh, this is made by Enshu.
Enshu.
E-N-S-H-U. I believe they still make milling machines, but of course it's all now CNC stuff.
And everything on its metric, right?
No, it's an interesting mix of the fasteners. For a lot of them are imperial fasteners. These gears are module. The lead screws are metric. Possibly, if one of you knows or have seen a lot of this size U.S. mills, I keep thinking this may have been copied from a Brown and Sharp or something like that, but I don't know that is true. The presence of imperial fasteners would indicate to me that maybe this was built under license or something like that.
Great. Thank you, Carl.
Alrighty. See you guys.
All right. Here's Howie out here. He's going, I got to be in the video. Huh. Hey, let's go. So you can see he went to the groomer, and he's got his Thanksgiving Day dress on there. I think he'd look better with a shop towel around his neck myself. But he wants to play, so I guess we'll go play.